A spring is the part of the suspension system primarily responsible for a smooth ride. It supports the weight of the vehicle. When a moving car encounters a bump in the road, the wheel is pushed up into the body. At the same time, the spring is compressed. The compression of the spring prevents the body from being forced upward. Then, when the car moves past the bump, the spring releases its energy and pushes the wheel back onto the road.
The release of the spring's energy reduces the time the wheel is out of contact with the road. In this way, a spring works both to absorb bumps and maintain road contact. Now let's examine different types of springs used on cars.
Most suspension systems use coil springs. A coil spring is a steel bar rolled into a coil. Different sizes and capacities of springs are used on different vehicles. This is a spring used on a passenger vehicle.
Springs are mounted in various ways depending on the driveline configuration and whether they are on the front or rear of the vehicle.
For example, many front suspensions have springs that are mounted in conjunction with upper and lower control arms. Coil springs are compact and have a progressive spring rate. This means that as a coil spring is compressed, its resistance to further compression increases.
Another common type of spring is the leaf spring. Leaf springs have been used on cars for many years. Here you can see leaf spring suspension on a Ford Model T. Today, leaf springs are used on trucks and some passenger cars. Leaf springs are mounted to the rear axle housing. A leaf spring is basically a series of bent flat bars that support the weight of the vehicle. The two ends of the spring are attached to the frame. The center is attached to the axle housing. This enables the wheel and housing to move up and down. As the leaf spring flexes, the metal bars slide over one another. Insulating layers of plastic are sometimes placed between the leaves to reduce friction.
Another type of spring is called a torsion bar. Like the coil and leaf spring, a torsion bar stores and releases energy. But instead of compressing or bending, the torsion bar stores energy by twisting, and it releases stored energy by returning to its normal position. The front end of a torsion bar is attached to a lower control arm. The rear end is attached to the frame. The pivoting of the control arm twists the bar. Torsion bars allow more underhood space by eliminating the coil spring towers.